Hi guys, so this is just a little short video on rational functions and how to find vertical asymptotes. So just to talk about vocab really fast, in chapter 2 we talked about quadratics, in chapter 3 we talked about polynomials, chapter 4 is all about rational functions. What a rational function is, it is basically a polynomial divided by a polynomial, okay? It says a rational function is any function defined by a rational expression such as r of x equals p of x over q of x, where p of x and q of x are polynomials. And obviously my denominator cannot be equal to 0. This is an example of a rational function. The difference between an expression and a function is that it's right here. You can even compare and contrast this. That's an expression, and this is a function. A function has an equal sign, saying this equals this. An expression is just like a fraction. This is one big fraction. And here's that what I was talking about, the ratio of two polynomials. Ratio is a division, right? When I divide two polynomials. So this is an example of a rational function. Just some vocab for us. How do we find asymptotes? So this video is on how to find vertical asymptotes. So notice I can't just look for transformations. So like if it moves to the left 3, I know it creates a vertical asymptote. I can't do that when it's in this form. So what do we need to do? In order to find vertical asymptotes, all we have to do is I need to set my denominator equal to 0. Because we know in a fraction, my denominator can never be 0. Right? Take a second and put into a calculator 5 divided by 0 or 100 divided by 0. It's going to give you an error. I can't divide something by 0. So if it's impossible to have 0 in my denominator, what is there is an asymptote. Remember, it's never going to touch the asymptote. It's never going to cross over. So for that reason, that's why we set the denominator equal to 0, because it's never supposed to be 0. Whatever value we get, that's where there's an asymptote. And that's what we're going to go ahead and do. I'm going to take my denominator, just that x squared plus 7x plus 12, set it equal to 0, and I solve this however I can, and then solve. Okay, and I look at this, I see it's a quadratic, right? That square tells me it's a quadratic. How do I solve for x's? These x's when I have a quadratic? We factor, right? I needed to make that chart. Remember, it's two numbers that multiply to your c value, so that would be 12, and add to your b value, which is 7. Okay, add to 7, multiply to 12, and that's 3 and 4. So that's why I put them here. And then that last property we have to use is called the zero product property. That's how I solve for each of these x's. It tells me I need to set them both equal to 0 and then solve each of these separately for x. So how do I get this x alone? I subtract 3. And how do I get this x alone? I subtract 4. Here are my vertical asymptotes. And that's all we have to do. How do we find vertical asymptotes? Set the denominator equal to 0 and solve. So sometimes we won't be factoring. This is even an easier example. If I wanted to find the vertical asymptotes, I say, okay, set my denominator equal to 0, solve. How do I solve this? Subtract 4 on both sides, and there's my vertical asymptote, right? It just depends what type of function you have and how you're going to solve it. So if it's some basic algebra like this one, get the x alone, subtract the 4. Maybe it's a quadratic that I'll have to do some factoring though. All depends on what this expression is, okay? And that's how to find vertical asymptotes, guys. Awesome job.